Welcome to another nostalgic ramble. Today we are looking at IEB November 2023 paper 2, and this question deals with trig graphs. So question 6, let's go. We are given f of x is equal to sine of 2x and g of x is equal to cos of x plus 45 for x in this restricted domain, minus 90 degrees to 180 degrees. So the first question asks us to sketch the graphs of f and g on the same set of axes, and we need to label all the intercepts with axes, all the turning points, and all the end points. Okay, so with these questions, where there are transformations, it's important to always remember like what each, how can I say, so like how the most general form of the trig graphs that we deal with will look something like this, right? So yeah, it's important to know what each of these does. Come on. Right, this. Okay, and just to quickly run over what they each do. This is a vertical stretch, right? So if your original graph looks like this, then the vertical stretch might look something like that, or it might even look, squashed. Okay, something like that. Okay, and then the next one is this guy who also does a stretch, but horizontal stretch. So this will then be, say the graph will look something like that, right? Or it will look like that, right? Like it's going super slow, right? So that's the impact of that guy. This guy is in charge of shifting horizontally, so your graph will look like that maybe, or it will look like that. And then the last guy is in charge of vertical shifts, so your graph moves up or your graph moves down. Okay, so it's important to know those things offhand, right? And so if we look at the two functions that we've been given, okay, the first one, sine 2x, so that is a sine graph that has been squished horizontally, right? So that's one that's going to be a quick squiggle. Okay, and it's a quick squiggle because of the 2. If it had been sine of a half x, then it would be a bit more stretched out, right? And then the second one, cos of x plus 45, we have that horizontal shift to the left. So if your normal cos graph looks that, then cos of x plus 45 will look something like that. Okay, so how I like to do these sketches is I like to get a sense of what's going on relative to the original graph, and more specifically I like to look at what I call my steering points, the main characters. So let me just write more than I'm speaking, because clearly the speaking is not working. So I like to first think about, okay, what does y is equal to sine x look like? And I'm going to draw this nice and big for myself. And I look at it from 0 to 360 degrees, so one full wave. So I know that it will do that, for example. And my main characters, as I call them, are my x-intercepts and my turning points. Okay, so this is the first x-intercept, the next x-intercept, and the last x-intercept. Okay, and then over here my first turning point is 90 degrees and 1, and then the other turning point is 270 degrees and -1. So that is what I just know offhand, right? Also important to just know the structures of your 3 trig graphs, just offhand. So with your sine and cos, know what it looks like from 0 to 360 degrees, because from there it just repeats itself. For your tan graph, know what it looks like from negative 90 to 90 degrees, because that is one full wave of the tan graph, and from there it repeats itself. Okay, so if I now want to think about what the graph of y is equal to sine of 2x looks like, okay, it's a bit weird. I don't know. I hope I'm going to describe this in a way that makes sense. But I basically try to think about which points, how can I say this? So maybe naively, I try to think about what happens to these points, right? Under this transformation, what happens to those points? Okay. And because we know that y is equal to sine 2x, what have I done? Y is equal to sine 2x is a squish, right? It's a squish, it's not a stretch, so it's going to do that, right? And because of that factor 2, that means that I almost like to think of it as things happen twice as quickly. I don't know if it's very accurate to think of it that way, but yeah. So, I mean, half of 0 is still 0, so this point remains where it is, right? And you can just test that, right? Sine of 2 times 0 is still just going to be sine of 0, which we know is 0. So that point doesn't change. So it's almost like the squish. Okay, yeah, let me not go there. Oh, I rubbed out everything. My eraser is a bit too violent. Okay, then I look at this next point. Okay, and where does that point go under this transformation? So it is going to happen twice as early. So it's going to happen over here, right? So that will be 45 degrees and 1. And again, you can double check this. Sine of 2 times 45 is sine of 90, right? Which is 1. So it's this point. Okay, sine of 90 is 1. But because of this transformation, it's happening over here. And I know it looks slightly lower over here, but just pretend they're on the same level. Okay, and then you can guess what happens to this point. Also happens twice as early. Okay, so it is going to happen at 90 degrees. Right? This point will happen at 135 degrees. Okay, 135 is half of 270. And then lastly, this point is going to come here, right, to 180 and 0. So then our graph looks like this, at least the one wave of it, right? And from 180 to 360 degrees, you're going to get another wave. But anyway, that's not the point. And this kind of, yeah, okay, let me not waffle on too much, but I hope that makes sense, right? So I looked at each of these points and kind of performed the transformation on them individually, right? And this is the result that I get. These are the 5 points that I got as a result, and then the curve kind of connects them. So let's plot that over here. So we have 0, 0, 45, 1, 90, 0, 135, minus 1, 180, and 0. All right, so it looks like that. Okay, I am drawing with bandaged fingers, so I'm trying to be a bit hard on myself, but yeah, there are limitations. And then once you have the one curve, it's easy to figure out what must happen on this side. Okay, so we can see that we hit our turning point within one block, in inverted commas, so the same will happen this way, right? And then we're back up to the x-axis in the other block. Okay, please draw a lot more accurately than me in your exam. They will dock you. Okay, let me not say that like I've ever marked a maths exam, but I will dock you in a test if you drew as sloppily as I have drawn. Okay, so 135 minus 1, and this is 180 and 0, and then this is 0, 0, and then we've got minus 45 and minus 1, and then we have minus 90 and 0. Okay, so that's our first one done and dusted. Nice. Just going to shrink this, if I may, guys, if all the forces in the universe will not oppose me. Okay, I don't know what I left behind, but it doesn't look too important. Okay, so I'm going to move this up here. Okay, right, then the second graph we're looking at, the second function we're looking at is y is equal to cos of x plus 45. So plus 45 being added to the input, the x, so that means our graph is moving 45 degrees to the left. Our y is equal to cos x, right? So again, I'll start by looking at one wave from 0 to 360. Okay, and that looks like this, right? Where this is 0 and 1. This is 90 and 0. This is 180 and minus 1. 270 and 0. 360 and 1. Okay, so now and this is let's label that. So this is y is equal to cos of x, to need a bracket there, y is equal to cos of x, right? So now if we want the graph of y is equal to cos of x plus 45, okay, again I'm going to look at all of my main character points and ask, well, where are they now? Under this transformation, where do they go? So 0 and 1 ish, unfortunately, okay, not unfortunately, I can't do something about it. I am going to try and move this graph. No, it's moving everything. Why are you moving everything? I'm not sure. Getting a phone call and wondering if it is important. I am deciding that it is not. Okay, yeah, that's kind of good enough. Oh. Okay. Oh, if it turns out it was important, it's going to be very awkward. Right, so anyway, all this pain, just so I could extend this a little bit this way. So this point will now be 45 degrees earlier, so it will be at negative 45 and 1. Okay, then up next, this one will be at 45 and 1, not and 1, and 0. Okay, this one will be at 135 and negative 1. This one will be at 225 and 0. And then lastly, this one will be at 315 and 1, right? So then our graph ends up looking like that. Oh, guys, sometimes these intelligent things are not very intelligent. It makes me angry. Okay, right, so let's move that up to the top. So first up, we have negative 45 and 1. And then the next point we had was 45 and 0. And then 135 and minus 1, right? Yes. And then 225 would be the next x-intercept. So 180 is going to be somewhere there. So let's just say Well, and we can actually work that out a bit more accurately just now. But let's just put it there for now. Okay, and then on the other side of negative 45, well, so things are currently looking something like this. Very questionable. Okay, there's only so much you can do, dummy, with your bandaged fingers. Okay, so we know that it takes 2 blocks, right, to travel from a turning point to an x-intercept. All right, again, over here from x-intercept to turning point, it takes 2 blocks. Okay, so from minus 45 to 90, we're not going to get to the x-axis within that 1 block. So our graph is just going to end up roughly somewhere there. Okay, so now we need to work out what. Okay, wait, first let's label. This brain thinks of a number of things at once. Okay, right, so 45 and 1. Why do I keep saying and 1? Maybe I'm thinking of 10. Okay, so now we can work out the endpoints. So we want to work out what is g of negative 90. In other words, cos of negative 90 plus 45 degrees, which is cos of negative 45, which is the same as cos of positive 45, right, from our reduction rules, and that is the same as root 2 over 2. So, yeah, definitely not going to fit it in there. So I'm just going to write it here, and then I will shrink it. Okay, right, so that's the one endpoint. Okay, can I? Good. Maybe I want to move all of these also. Let me just quickly do that. This is going to be interesting to say the least. Now I can't. Oh, guys, calculator is like I have been stowed away for too long. And I'm like, why do you think you get to decide that, calculator? Why? Because now my things are just being disrupted in a big way. Okay. Alright, let's see if we can get you. Nope, we can't. So we shall just erase you. And then we will do that. And then we'll try again. Like good mathematicians. We never give up. Okay, I think that's small enough. Oh God. Okay, wait. So let's move that down here. And then this can come up here. And maybe just a bit smaller. Okay, right. Anyway, so now we want to work out the coordinates for this endpoint. So that is when x is 180 degrees. So that is cos of 180 plus 45, which reduces to negative cos of 45, okay, which is negative root 2 over 2. So we have there 180 with negative root 2 over 2. Okay, and those are our two graphs with all of our important points labeled. Let's double check with the memo. Bandaged fingers. I'm having an interesting time. So we have, well, they've given it to us as decimals. I'm gonna trust myself. But yeah, I think we are in concurrence. I think we are. Okay. Oh, oops, forgot to label the y-intercept. Jeez, my bad. Okay, so y-intercept, let's shrink this one. Okay, so y-intercept of g, we're looking for where this guy no. Those are x-intercepts. Okay. So we are looking for g of 0. Okay, when x is 0, what is the y value? So that will be cos of 0 plus 45, which is cos of 45, which is also root 2 over 2. Okay, so this will be 0 and root 2 over 2. So that would be this guy. Okay, what else did I miss? Everything else seems to be good. Yes. Okay, so now let us try and take this to the next page. Okay, and off we go to the next page. Oh my goodness, what a tragedy. Oh, how does that even work? Golly. Okay, no, that is not going to work. Can I not? Am I frozen? Oh, goodness. I am. The poor app is calling time. Okay, I'm going to need to exit it maybe and try to open it again. I agree. Let's just pretend that didn't even happen. Okay, so let's just then duplicate the page. Okay, and then we're just going to have to erase a whole lot of stuff, which is going to take a minute, a literal minute, in which I could be spewing lots of useful information, but that would require me to be good at thinking on my feet, which I don't attribute to myself, ascribe to myself as a particular strength of mine. So, okay, that looks better. I'm going to duplicate this as well, so that, no, it's not what I want to do. I want to duplicate it so that question C can also use the same graph, yes. Okay, now we need to move the questions. So this would be an example of, a benefit of looking at these questions up front is I could do some preparation. But I really don't want to, give you let's not call it a watered down version of my thinking, but also maybe that is what it is. I wonder if I can select all of these and say cut. I can. Right, and then I want to paste them here. Slightly awkward. It wants to. Why did it? Oh. Okay, I want to shrink it. Okay, so it is a bit weird, but I think we'll be fine. Okay, anyway. Right. So the question we are on now is B. We are asked to determine the values of x that are between minus 90 and 180, both inclusive, for which f of x is equal to g of x. Show all calculations. Okay, show all calculations kind of hints that we're going to need to do calculations. Anyway, so we need to figure out where that point is, what that point is, okay? And okay, we can see that this is another place where they intersect. But yeah, we need some workings to figure out the other point. So we are solving the equation sine of 2x is equal to cos of x plus 45. Okay, so if both of these had been the same expression, then we could have used the nifty trick of dividing both sides by cos of that angle and then converting the resulting expression into tan, so using that tan identity, but they are not the same expression, so we can't do that. So then what we need to do is we need to use our knowledge of co-ratios to express one of these. So express this as a cos or express this as a sine. So I'm going to use the fact that which one is easier to potato. So either one I think is either one is fine. So I'll rewrite this one as a what am I saying? Not in terms of sine, as a sine ratio. Okay, so wait, okay. So the relationship I'm going to use is sine of guys, wow. Okay, so I'm going to use the relationship that says, no, that is not the relationship I'm going to use. Yes, it is. Oh, golly. I'm going to use the relationships that says sine of 90. No. Okay. Cos of some angle is the same as sine of 90 minus that angle. Wow, that took a lot out of me. Okay, so let's just put that onto one line. Okay, so this is the result that we're going to use. Okay, so using that result, we can say that cos of x plus 45 is the same as sine of 90 minus, okay, brackets are important here, okay, 90 minus that angle, x plus 45, which is sine of 90 minus 45 is just going to be 45, and this will become minus x. Okay, so essentially now that allows us to rewrite our equation as sine 2x is equal to sine 45 degrees minus x. Okay, and remember that there's two ways that this can be true, right? It could be that if we think about cost, okay, The places where we're dealing with a positive sign ratio is in this quadrant and in this quadrant. Okay, so if we imagine that 2x is some angle over here, okay, then it's either 45 minus x is also over here, or it could be the related angle over here. Okay, so those are the two ways that this can be true. Okay, so let us write that out. So it's either 2x will be equal to 45 degrees minus x, and remember, it could be that they are exactly equal, or 45 degrees minus x could be, 2x plus however many revolutions added or subtracted from it. That will all end up on the same place, on the Cartesian plane. So that's case number one. Okay. The second possibility is that is that 2x could be the same as 180 degrees minus this angle. And again, we could add or subtract a whole lot of revolutions to that. Okay. Right, and it's also always important to just say what k is. Oh my goodness. Nope. Okay, let's try one by one. How big is this picture? Oh my goodness. Oh, come on. Why is there so much white space on it? Okay, I'm just going to quickly crop. Did I crop? I did not crop. I don't know what I'm doing. Okay, discarding that and trying again. So I want to trim the white space. That's all I want to do. Okay, yes. I think we should be fine now. Okay, and now I can move this in almost perfect piece. Okay, fantastic. Right. So I'm just going to say here that k is any integer, so I can add or subtract as many revolutions as I like. Okay, and so then we proceed to add x on both sides. So we're just going to deal with each solution one at a time. Okay, and then we're going to divide by 3. So then we have x is 15 degrees plus 120 times k. Okay, and we are specifically looking for solutions between -90 and 180. Okay, so this is the general solution. Okay, so the more specific solution for our case, we can say, well, 15 degrees plus no 120s, right, if we make k 0. So that's the one option, which gives us 15. And from our diagram, it suggests that that's pretty much the only solution we're going to get out of this. But let's just see if we were to add 120 times 1, then we get 135. Oh my goodness, sorry, my bad. So that gives us 2 solutions. And if we try to add another 120, so 120 times 2, then we're going to end up with 255, which is too big, right? That's out of the domain we're looking at. Then if we look at 15 degrees plus 120 times minus 1, right? So 15 minus 120, that'll be negative 105, which is also outside of the domain we're looking at, right? It's smaller than negative 90. So this is not it either. It's too small. So these are the two solutions that we get out of this solution, right? So therefore x is 15 degrees or x is 135 degrees. And we can just double check now that this is not going to give us any relevant solutions, or it might give us overlapping solutions. Is that possible? Yeah, I guess it is. Let's see. So we would say, okay, 2x is 180 minus 45 is 135 plus x, yeah, plus 360k. Okay, and if we minus x on both sides, so that'll give us x is 135 degrees plus 360 times k. I feel like people more often say k360, so I don't know why I'm writing it this way. But anyway, so yeah, so we can see that the solutions we're getting out of that are x is equal to 135 plus 360 times 0, okay, which gives us just 135, which we've already gotten, or x is 135 degrees plus 360 times 1, that's going to be too big. That is 495, so that is too big. Or we can look at x is 135 degrees plus 360 times minus 1, which is 135 minus 360, and that is going to be too small to give what the answer is. Right, it's minus 225, and that is too small. It's smaller than minus 90. So our two solutions occur when x is equal to 15 or x is equal to 135. And we already have the 135 solution. Okay, so here we're getting a 15. Okay, and we need to figure out what the y coordinate is. And we can do that shortly when I've done a bit of cleaning up. I really wish that certain finger motions would not trigger certain things on this beloved app. But otherwise, it is an app. It is an absolutely fantastic app. Right. And all of this came from this. Okay, right, so we're trying to find the y coordinate when x is 15. So we're trying to find g of 15, which is cos of 15 plus 45, which is cos of 60, which is a half. Okay, and if you're wondering how I know that, I have a video about remembering your special angles. And I talk about one method that I use, but another very easy way to remember your special angles, and I'll just slide this in over here before we move on. Maybe I'll make a little spin-off, not a spin-off video, but you know, I'll just extract this part. What have I done? What's going on, right? Oh, did I leave something behind? This is weird. I don't know what's going on. Okay, anyway, let's just quickly move this question. What? Oh my goodness, my heavens and my earth. Whew. There are some strange idiosyncrasies up in here, man. Anyway, okay, fine. I'll just do it here. So, special angles. Okay. First, really easy one. And well, let's talk about what your special angles are. In this case, I'm just going to talk about 30, 45, and 60, but sometimes it's also 0 and 90. Are they really special? Anyway, okay, so 30, 45, and 60. 45, we just have to think about a right angle triangle containing a 45-degree angle. Using angle sum, we know that the other side is also 45, and therefore this is an isosceles triangle. Okay, so if we were to say this side is 1 unit long, then this side is also 1 unit long. And using Pythagoras, we know that 1 squared plus 1 squared is equal to 1 plus 1, which is equal to 2. So this side is going to be the square root of 2. And based on that, you can get your trig ratios for 45, right? Sine of 45 will be opposite over hypotenuse. Cos of 45 will be adjacent over hypotenuse. And if you look at it from either this one or this one, it'll give you the same ratios. And then finally, your tan ratio will be, so tan of 45 is opposite over adjacent, which is 1. Okay, so that's your one triangle. Then your other triangle is your 30, and this will be 60, right? They are complementary angles. And the side opposite to your 30 is 1, and this guy is 2, and this one is your root 3. Okay, and how do I remember that? Well, I just remember that there is a 1, 2, 3 in the triangle, and I mean it can't be 1 squared plus 2 squared, right? Because that's going to give me 1 plus 4, which is going to give me 5, and the square root of 5 is not 3, right? So it can't be a situation where I have 1, 2, 3. Okay, so then that kind of reminds me that one of them has a square root, right? And it can't be the 2, right? Because if we did that, square root of 2 is obviously smaller than 3, right? Because 2 is smaller than 3, so square root of 2 is definitely smaller than 3. So if the square root was on the 2, then I would have that. Square root of 2 squared is going to be 2, which gives me 3, and the square root of 3 is definitely not equal to 3, right? So the square root is not sitting right there. This is really like if you've completely forgotten, like ideally just remember that the square root goes to the 3, right? But if you've completely forgotten, these are some ways that you can sanity check yourself. So we can double check here. If I say 1 squared plus root 3 squared, that gives me 3 over there, and 1 plus 3 is equal to 4. And the square root of 4 is equal to the other side, which is 2. Right, so this is the correct, these are the correct 3 sides. It's 1, 2, and square root of 3, right? Then from there, we can just use our knowledge of, well, the smallest side is opposite the smallest angle, the medium side is opposite the medium angle, and the largest side is opposite the largest angle. So obviously our largest angle is 90, and which number is the biggest between these 3? Well, it's 2. 2 is the square root of 4, 1 is the square root of 1. So this is the biggest, this is the second biggest, and this is the smallest. So it makes sense that the 2 is over there, and that the 1 is over there, and then across the 60 you have the medium side, which is the square root of 3. Anyway, so that's a very long-winded explanation of another way that you can use to remember the ratios for your special angles, right? Because sine of 30 will be opposite over hypotenuse, cos of 30 will be adjacent over hypotenuse, and tan will be opposite over adjacent. Likewise for 60, sine of 60 will be opposite over hypotenuse, the cos will be a half, which is where all of this started, and the tan ratio will be opposite over adjacent. Whew, my goodness, my voice box is throbbing. Right, so we now know that, original question, determine the values of x for which f of x is equal to g of x. So we don't even need we don't even need this value. Anyway, so the values where they are equal are then just these two. All right, it's where it's x is equal to 15 or x is equal to 135 degrees. Right. What does the memo have to say? The memo is an agreement. What? Yes. Okay, cool. We are good. It looks like we don't need to look at the two quadrants. Do I believe that? I don't know if I believe that. Yeah, I would say you should always look at the two quadrants because it's, you can't say that if cos A is equal to cos B, it doesn't imply that it's because A is equal to B plus a couple of revolutions, you know. You have to consider the case where A and B are in different quadrants. Yeah, so I don't know, IEB teachers, maths teachers in general, but IEB teachers because this is a paper you came across. Please correct me if I'm wrong, but I do think that you have to consider both cases. Anyway, right, on to the last question. Jeez. So in this question, we also have a bit of knowledge. We know that this is 15 with a half. Right, and the previous question didn't give us more information than that. Right, so we are asked to use our graph to determine the values of x which are in this domain, or in this interval, for which f of x is greater than or equal to g of x. Okay, hence working out points of intersection. Right, f of x is the green graph. Just going to highlight it for myself. Okay, and we are looking for the places where f of x has a bigger output or bigger y values than g of x, or places where f of x is above g of x, and we can see that that is happening over here, right? So before this point of intersection, f is underneath g, and then after this point of intersection it goes above it up until here where, even after. It's just my terrible graph drawing skills, but because these two don't intersect again, so then we know that the pink graph actually does remain underneath the green graph despite my terrible sketching skills. So it's actually from here and until the 180 degrees. So that'll be 4, let's write it in interval style, right? So greater than or equal to, so that's from the 15 degrees up until and including the 180 degrees. That's where f of x outputs y's that are greater than or equal to the y's that g outputs. Then we're looking for spaces where, or the intervals of x where f of x times g of x is strictly smaller than 0 or negative, right? And there's two ways that can happen. So we are looking for places where f is giving us positive values and g is giving us negative values. Why am I getting 0 now? Right? Or places where f is giving us negative values and g is giving us positive values, right? And these questions, I don't know, maybe now that they've kind of featured in the exams a bit more frequently, they're less weird, but sometimes I have found that, as students, well, and let me speak for myself, I think as a student, did we have these questions back in my day? But anyway, like initially they did feel like, wow, what is happening here? So let's just begin by getting a feel for thought I knew what this does, and now I'm realizing I don't. Oh, there we go. Okay. Right. Okay, so let's say, for example, we took x is equal to minus 45, right? When x is equal to minus 45, the output of f is negative. Okay. Oh my goodness, what is happening? Oh, I hate being surprised by technology. Okay, right, let's set up again. Okay, go back to x is equal to minus 45. Okay, so when x is equal to minus 45, the output of the graph of the function is negative. The output of the g function is positive. So that means if I was to take f of x over here, f of minus 45, and times it with g of minus 45, I would get a negative number. So x is equal to minus 45 is one of the solutions to this inequality, right? Let's look at another point. So let's look at when x is equal to 90. When x is equal to 90, my f function outputs 0. My g function outputs some negative number, right? So if I times those outputs together, I get 0. So that means when x is 90, so x is equal to 90, isn't a solution to this inequality because those outputs times together gives me 0. We're looking for values of x where the outputs times together is going to give me something negative. Okay, let's look at one more example. Let's look at when x is equal to 135, right? When x is equal to 135, both of these functions output a negative number. They output -1. And if I times -1 with -1, I'm going to get a positive number. So x is equal to 135 also isn't part of the solution to this inequality because when x is 135, both of these functions output a negative number and the product of two negative numbers is positive. So now that we kind of have a sense of what we're looking for, right? Well, I guess I highlighted here as well. We're looking for places where f is giving us positive y values and g is giving us negative ones, or f is giving us negative y values and g is giving us positive ones. Okay, so thank you, Mr. Ruler. Let's look at where f is giving us positive y values. So I'm going to highlight that with a different color. It's giving us positive y values from 0 until 90, and that's it, right? The rest of the time it's giving us negative y values. And in that interval from 0 to 90, okay, where is g of x giving us negative values? So if we look at what's happening with the g graph between 0 and 90, we see that it starts out giving us positive y values, okay, positive y values. I can't see my little pointer. I'm just going to believe that it's there. Okay, so it's giving us positive y values there, but after 45 it gives us negative ones. So over here we're now getting negative y values. So this is the interval, this is one of the intervals where this condition is satisfied, right? From 45 until 90, right, we have f giving us positive y values and g giving us negative y values. Okay, so we're going to write that down. From 45 until 90, okay? Then, depending on this operator, whether it's less than 0 or less than or equal to 0, this is what helps us decide what we must do with the boundaries with 45 and 90. Do we include them? Do we not? So let's see what's happening at 45. At 45 degrees, right, that is where g has an x-intercept. In other words, the output of g is 0 at that point, meaning that this product at 45 degrees, when x is equal to 45, the product of the two functions output is also 0. So 45 is not part of the solution, right, because the product is equal to 0, it's not less than 0. So we're going to exclude 45. What about at 90 degrees? Okay, at 90 degrees, similar thing happens. F has an x-intercept, right? So even though g is negative over there, right, because f has an x-intercept, that means the output of f is 0, meaning that 0 times whatever is going to give me 0 as well. So 90 does not qualify. Okay. Right, 90 does not qualify me. So this is also going to be an open bracket. Right. So this is the first part of the solution, potentially. Okay. Then we're going to look at the second scenario, the scenario where f is giving us negative y values and g is giving us positive y values. Okay, so let's start by looking at, well, let's start by erasing my highlighting. Okay, so let's look at where f has negative y values, and that is going to be over here and over here. Okay, right, so in those intervals, i.e. when x is between 0 and minus 90, and when x is between 90 and 180, where is g of x positive, i.e. where is g giving us positive y values? So g gives us positive y values over here, right? So for that whole interval over there from minus 90 to 0, we get positive y values. And then in this interval, we don't see g above the x-axis, it's only down here, right? So in this interval, we don't have g outputting positive values. So this over here is the only interval where this condition is met, f of x negative and g of x positive. So let's just write that algebraically. So that will be from minus 90 degrees until 0. Okay, so then let's see what's happening at the boundaries. When x is equal to 90, the f function outputs 0, which makes this expression 0 as well. So we don't include minus 90 in the solution. And similarly at 0, right, the f function again outputs 0, making this function, this product equal to 0, and so it is also not part of the solution. Okay, so that gives us our solution. Okay, the product of the two functions' output is negative when x is between negative 90 and 0, or, which we can indicate with a union, it's between 45 degrees and 90 degrees. Okay, let's see if the memo agrees. So we have, well, 15 to 180 for the first solution, yes, both included, both boundaries included. And then for the second one, we have x is between negative 90 and 0, and x is between 45 and 90. Yeah, awesome.